Okay, ladies and gentlemen, lesson 25 is on relations and functions. So, first we're going to talk about domain and range. Domain is the set of possible values for the independent variable. An independent variable deals with x values, or the input value, so whatever you're putting into your problem. The range is the set of possible values for the dependent variable. Those are y values, or the output value. So domain is what you put in to a problem, and range is what you get out of it. So if we look at these ordered pairs, the domain is the x's. Okay, and when we list domain, we list them smallest to largest, and we only write a number once. So if we look here, 2 is my smallest number in the x's, but I have 2 of them, but that I'm still just going to write one of them. Okay, then my next one I see is 3, and 4, 5, and 8. Okay. And my range, you do the same way. You write each value only once, and you go smallest to largest. So 1 is my smallest value. Then next I have 6. I have 1, 2, 3 6s. Now remember, I only write it once. Then I have a 9, and last I have a 10. And we put them in the braces, those swirly lines. Okay, so a relation is a set of ordered pairs where each of the numbers in the domain is matched to one or more numbers in the range. So a relation is sets of ordered pairs, and you will see that we have this diagram here, and our domain values are listed in the first oval, and our range values are listed in the second oval. And you see that there is an arrow from every x to every y. So they match up. And there can be, here we have 2 goes to 2 different numbers, and that is just fine. And 6 has 3 numbers that comes to it. That's just fine. Next, we're going to talk about a function. Function is very similar to a relation, except the big difference is a function is a set of ordered pairs where each value, x value, goes to only one y value. So that means in this set of data here, in my domain, every x arrow, or every x only has one arrow coming from it. Okay, notice that there's only one arrow out of each of these x's. If there was 2 arrows coming out of it, it would not be a function. Now you'll notice this y has 2 values that comes to it. That is just fine. You could have 1, 2, 4, 6, and 9, and you could have them all go to 7, and that is okay. You can have as many x values go to y, but it needs to have only one arrow from the x's. All right, vertical line test. So if you have graphs, vertical line test is going to help you determine if you have a function or not. If you have a vertical line and you take it and you move it along your graph and it only ever touches one point at a time, this is a function. Okay, let's try it over here. We're running it along and it only ever touches the line once at a time, function. Okay, so if I take my vertical line to this last one, I see here that when I'm running, I am touching 2 different points at a time. If I move, oops, I want to move my line, not my graph. If I move my line, again, I'm touching my graph in multiple places. So this is classified as not a function. Okay, so we have functions and not a function, but all of these are relations. Okay, let's get into those lettered problems. Give the domain and range for the relation. So domain, okay, lists smallest to largest. So 1, 2, 3, 4, 7, and 8. Remember, I'm just writing my x values. We write them smallest to largest and one at a time. Okay, range. I have a 1, a 2, then we go to 5, 6, 7, and then the last one is 10. That's listing them out. Okay, smallest to largest, each value only once. Using a diagram, determine whether the ordered pairs represent a function. So when it says using a diagram, that's where we're going to do our 2 ovals for domain and range. Again, We're going to list them smallest to largest. So 5, then we have 11, we have 12, 13, and 14. Put it in an oval. Then my range. I have a 1, then I have a 5, 7, 10, and 12. Okay, and the last thing I have to do is use my arrows. So I'm just going to go at my ordered pairs. 11 goes to 12, then 12 goes up to 1, 5 goes to 5, 14 is going to go to 10, and 13 is going to go to 7. So do I have one arrow coming out of every single x and one only? Yes, so yes, a function. All right, determine whether y equals 3x represents a function. So remember, everything we put in for x is only going to get us one thing back for y. So let's just pick any random number to plug in for x. So let's try x equals 2. Okay, so y equals 3 times 2 minus 1. So we get y equals, order of operations says we do multiplication first, y equals 5. And here, we can only get 5. So, yes, function, because we don't get two values. All right. Use the table and graph the ordered pairs on a coordinate plane and determine whether the ordered pairs represent a function. Let me grab a graph here. Okay, we have our graph. So, we're going to graph -1, 3. So I'm going to go -1 and up 3. Then I'm going to graph 0, 0. Then I have 1, 3, so over 1, up 3. -2, 6, so over -2, up to 6. And 0, 6. So I'm at 0 and I go up to 6. So we want to know, is this going to be a function? So if I use my vertical line and I run along here, I only touch 1, I only touch 1. Here, I'm touching 2 points, so not a function, because I touch 2 at a time. All right. Brochure costs 7 cents per page to print. Write a rule in function notation to represent the cost of printing C copies of the brochure. Function notation is when we say f of whatever our variable is. And so that's C in this case. So we could say f of C, and that's the same thing as saying y equals. Okay, 7 cents per page. Okay, so 0.7 per page. Function notation. F, an author writes 30 pages per day. Write a function rule that the author can use to find how many pages she has left to write before reaching page 400. Okay, so that means we have our F of, and since we're talking about how many pages, let's pick P. No, I think that problem wants to know how many days, because she writes pages per day. Okay, so function of D, days. She wants 400 total, and she writes 30 a day, so we're going to minus 30 per day. All right, there you guys go.